What's up, people, and welcome to my tutorial in pragmatic data science. So in the previous video we created a sample with a reservoir sampling into 1,000 items, and in this video we're going to do similarity on that sample. So as in the previous video, I also have this pickling thing going on here. You can dump variables and load them from disk. And then I'm going to build up a similarity matrix using a similarity function here for each document. So I'm going to start by loading in the sample data, build up the similarity matrix, and dump that to disk. So let's check out what this bad boy here does. So it's going to check how many documents there is. So this is n here. And then it's going to create, with NumPy, it's going to just create a matrix with that size, n by n matrix here. And then it's going to calculate it with the complexity here is, as I said, a Cartesian product. So it's an n by n matrix, and it's going to calculate the similarities between two different documents I and j here. So here is like the nasty complexity, and then put that on the index ij in the matrix with the similarity function between document I and document j. So of course you don't have to do the Cartesian product here. You could do better. You could do better than Cartesian product, because in our particular case it's actually doesn't matter, because in the diagonal here you would have if you think of this as a matrix, on the diagonal of that similarity matrix you will have 100% similarity, because the document will be comparing it to itself. And also you don't have to, it's undirected. The similarity in our case is undirected, meaning that song A is similar to B in the same way as B is similar to A. So you don't have to calculate them both ways as we do. But I do it anyway, so we will see what kind of issues we run into when we do that later. And also for simplicity, because the loops are getting a little more involved at this time. Then also this is like not a production code, right? So I have a similarity function here. I'm going to use a Jacquard similarity to begin with, and then later we will see what kind of problems we run into that. But Jacquard similarity or Jacquard index is a really common way of checking between dictionaries, especially if how similar these documents are. So from the Wikipedia article you can see that the Jacquard index can be calculated like this here. So it's like document A and B, and then you take the intersection of these over the union. So the intersection is basically this set here in the middle that they have in common over the union. So you can get an intuition here saying that it's going to calculate the coefficient for, or the index for how much they have in common over how much in total there is, or some, I don't know, but like that's kind of how I think of it, at least. And then so yeah, the intersection of the union. And the way I do that is I have document I and j here, as I showed you previously here. Send them in here, we get them here. I grab all the keys from the word dictionary that we created when we used the term frequency for the documents. And then the way you would calculate the intersection in Python is you would use it like ampersand here. So the keys here, these are dictionaries, or sets rather. And you'd use ampersand, you get the intersection. So the second part here is calculating the union between them. So you would take all the keys from set I, copy those over to a variable, then we use the update with the keys from j. So here in the union you would have all the words in together, right? And then you would just take the length of these and divide the intersection over the union. So you get some kind of similarity measurements here. So now you might be thinking, but hold on a second, why do you only use the keys here and not the TF-IDF score that we calculated later? So why do we go through all that? And the reason for that is because the Jacquard similarity is very common similarity measurements that you will see, especially when using dictionaries and sets. And We are going to use the TF-IDF later when we run into problems with this Jacquard similarity implementation. So first we need to fail with the Jacquard similarity and see why we do that, and then later we're going to use the TF-IDF and this implementation instead, and so we'll see what that does. But I don't want to dive into this now. Let's fail first. So let me go ahead and run this, and it's going to take a while to run through, so we don't have to look at all of it. But when it's done, it's going to create this similarity matrix bin here. I think I already have it here. Right. So that's basically all for this video. Dive into the code and check out the Jacquard similarity and the Wikipedia article so you know what it is about. And then I will see you in the next video. Don't forget to subscribe. See ya. Bye-bye.